current process takes about 41 seconds to roll cardboard, which costs about $35,000 between Mountaintop and Goodyear. If we remove just the pre-bend alone, that'll take 10 seconds off the total time and save about $10,000. For the mechanical requirements, we're looking at a motor, a speed reducer, a roller, and a frame design. For the motor, we need a 1 horsepower, 220 volt, 3-phase AC motor that operates in the range of 1700 to 1800 RPM. That motor is connected to our powertrain, which has a speed reducer. That speed reducer is geared 60 to 1, which then outputs to our gearing chain system. The gearing chains are hooked up to the main roller, and on that chain system we'll have a chain tensioner. The current design does not incorporate any kind of chain tensioner. As we can see, what we observe is that the chains are very loose and cause the system to bind and skip. On the rollers, they are powered with one central roller that I will be welding a C-channel onto that will help pull the cardboard through the system. There will also be idle rollers that will be laid out in the most optimal way, again, which we'll talk about in the design. For the frame, it will be constructed out of angle iron and all welded together. The motor and speed reducer will be mounted onto the frame, and the frame in the final version will be mounted into the ground. The electrical and automation requirements, we have our control panel, our PLC, the loading, and the stacking. For the control panel, we'll have our basic on and off switch, an emergency stop. We'll also have a motion direction switch, which will be forward and reverse. The current system, when you put the machine forward, you roll a piece of cardboard. If there is a jam, the workers are able to put it into reverse and back the piece of cardboard out. We will be adding a number pad into the system, which will be able to allow the user to input between 1 and 65, as there are currently 65 pieces of cardboard on each pallet. For the PLC, we are still determining the number of inputs and outputs that are required, but that will have the number of pads hooked into it, as well as sensors, such as current sensors on the motor. So if there is a jam in the automation scenario, the current sensor will pick up on it and cause the machine to stop. For the loading, we'll be using a lift table that will lift a stack of cardboard up to a roller system that will allow it to be fed into the machine. We also developed some kind of chute that will help guide the cardboard in so it goes in straight and in the same direction every time. The stacking will be optimal based upon our testing, which the ideal result is to have come out of the back and fall into a cart. This cart will allow the workers to take the cardboard to whichever bay they require it.
For some of the mechanical specifications for our roller box, this needs to be designed to roll a 7 by 4 foot sheet of 3-ply cardboard. This is what's currently used in the process. To help assist rolling cardboard, as Dom said, we're going to have pieces of C-channel loaded on to help pull these sheets of cardboard through. Additionally, this current manual roller needs to be designed with the future intent of automating the process. So we have to keep in the back of our minds a way to make this manual roller compatible, to be able to switch back and forth between a manual operation and an automated process down the road. Additionally, for our automated process, we're going to have a lift bed. This lift bed needs to be able to hold over 700 pounds. So that's the weight of the stack of cardboard, and it needs to be able to lift over 34 inches because that's how tall our pallets of cardboard are. For the auto feeding, to ensure proper alignment, we're going to build a chute out of sheet metal. This will help align the cardboard in a proper orientation. This is going to be helpful not only for the automated process, but to help workers place it in there in proper orientation every time. For safety, we're going to be following OSHA standards to make sure that there's nothing wrong safety-wise, so people working around the machine won't have to worry about any injuries. This is our work breakdown structure. This gives a quick guideline of all the different tasks that we need to complete during our project and lays them out into our mechanical, electrical, automated parts of the project. Additionally, we have a layout because we need to take into account the floor plan at the plan. For our schedule, this shows how long it's going to take for all of our tasks. Currently, we are slightly behind schedule for where we want to be at this time of year. We've had some issues getting parts in, but in the coming weeks, Brad and Dom are going to be able to get those parts and still manufacture everything and start testing, which will put us back on schedule to have our first deliverable to Cornell Cookston by the end of the year. For our budget, this gives a quick breakdown of the cost of all of our materials. Because this is an industry project, some of the materials such as the motor and speed reducer do cost a significant amount of money, but they have a budget for that. Our total cost spending that we're trying to keep everything under is the cost of manual labor to do this in 1 year. That way the company can recuperate these costs in the first year of having an automated process. This real-world cost shows that $36,000 budget of about the cost of manually rolling the cardboard. Additionally, we have the cost of shop labor to fabricate it, which we don't have to take into account because I'm going to be building it, and the engineering hours for just a standard engineering fee should they have outsourced this project to another company. To allow for any increase in cost of materials, we have a 10% contingency plan built in.
So some ethics that we had to keep in mind for this project is mostly safety, and also the ergonomics and health of the workers. So the current process, the entry feed is about 3 feet off the ground, and from my and Dominic's overview of watching the process, the worker has to bend over quite a bit, whether it's the sack of cardboard being low or the prevent and everything like that. They're back her at the end of the day. So we're trying to raise that up a little bit higher as well to help with the ergonomics of the worker. As well as we have to abide by OSHA standards and everything, safety requirements like that. We are not displacing any workers through this project. We are just making their job a heck of a lot easier. And this is our testing plan currently. Our current prototype is using a modular side plate design. This is just for prototyping. Our final product will only have the holes necessary on the side. But as you can see on the left, there's the 5 rollers with the center trigger roller. The current process feeds in the bottom and out the top. Our idea for prototyping this is by trying to cut out as many rollers as possible while still getting the successful result that we're looking for. We're going to do that one by one, and then when we get to a point where there's a failure, we go back and add the roller, and that's our safe point. As well as it being modular, we're going to have a straight line. This represents more of the sheet metal rolling process, which is kind of what we're basing it off of. This is the prime example or prime thing that we're trying to do for the automation, as we can get a better layout and actually have it feed out the back rather than back out the front, which adds more difficulty later on. And this just shows the end result of the rolled piece of cardboard. It's hard to tell, but only the top layer is creased. The middle and the bottom layer are not touched at all, which affects the rolling shape. And then this is we are kind of stuck right now with the design process, as we're not sure what the roll layer is going to be, so we can't design until we finish the prototype. But this gives a rough idea of how we plan to automate the process. We have a lift table with a pallet of cardboard, makes contact with the feed rollers, goes into the rolling machine, and it's going to go out the front or out the back. The folding table is the idea that we have currently to make it also a manual operation rolling box. Just in case one worker wants 1 or 2 pieces, they can easily do it themselves and not have to worry about the machine making it for them.
So the plan for next semester is going to be determining the number of inputs and outputs of the PLC. Determining the inputs and outputs will obviously give us the best PLC for the job, and we also work with Cornell on that, as they do have PLCs in the plant. So they will also guide us to what their best option is. We will be building the feeder system. Again, once we do all the testing and find that out, then we can predict the correct orientation for the feeder system. And then lastly, we need to edit Cornell's floor plan. It is a very tight plant, but we will be able to get it done as we will be saving space since there are multiple rollers in the plant right now. And then just to conclude, like I said, inputs and outputs are being determined for the PLC. The prototype is being fabricated as we speak right now. The project for Cornell is still on track. They would like to have the prototype done by the end of the year. What Dan was talking about was we were really trying to get the prototype done before senior projects today so we could show a demonstration. And then just some possible challenges we may run into is the lift bed integration. got some of the design advice from Mitch Adams, the machinist here at Wilkes, Tom Beaver, he's the machinist at Cornell, Jeff Wills is the fabricator at Cornell, and Hunter LaCombus is one of the engineers at Cornell helping us as well.
Any questions? Yes?
So can you go back to basically your first slide of you in the shop?
Yes.
Yeah.
There we go. Okay, so forgive me for it, but I'm not sure I understand what's happening here. Is that a motorized, what kind of machine is that you're using?
So this is a homemade machine that they made in the 90s, early 2000s. And pretty much you put the sheet of cardboard in this driven roller here, and there's 5 idle rollers in a C shape, and it just feeds the cardboard through and bends it as it goes through.
Okay, so you're building from scratch or you're modifying this?
We're modifying, but also building from scratch because we need to modulate, make it modular for automation purposes.
One of the current challenges with this design is the rollers are not aligned correctly when it was originally built, which is what requires the prevent. If you do not prevent the cardboard, it goes in and it jams. When we move the rollers down to be directly underneath the center roller, that will eliminate the use of the prevent because now the main roller can catch it and be pulled through.
Okay, so this, you're building one that has properly aligned rollers.
Correct.
Okay. You also mentioned that, like, does that side, how do you, let's say this thing jams, how do you create a jam from it?
So that's what the reverse switch is. So currently, if it jams, the worker goes over to hit the reverse switch, it spins the motor backwards and pushes the piece of cardboard out. For the automation, that's where I was saying the current sensor is that if it detects a jam, so a large spike in current in the motor, then what will happen is the machine will fault out, flash, red light, sound alarm, something like that, to alert attention to go over, and then reverse the machine and take the piece of cardboard out and reset it.
Okay. Okay. So are you guys going to be, are the three of you going to be handling all of the automation integration?
Yes.
Okay. Do you have experience with system integration such as that? Or is Cornell going to assist you?
Cornell is going to assist us as well as Dr. Zushin to assist us as well.
Okay.
Dan?
You know what specific OSHA standards you guys are going to follow?
So that's with the safety team at Cornell. They will, when we build a machine, they'll come over, I'll talk to them, and they'll say, okay, you have this hole here, we need a guarding such as this. They'll walk us through the entire safety standards for it. They will not let us put this in production without proper safeguarding.
Dr. B?
Yes, so as you're showing this slide, and I chronically have a bad back, I thought bigger than the cost saving is the saver to the worker.
Yeah.
So I'm glad, Brad, later on you did mention that more, that, you know, that you're really
Yeah.
alleviating that painful step over and over all day long.
So what you can't see here also is the stack of cardboard is about yay tall behind Dominic.
That front.
So not only have to reach really high, but his posture is pretty poor in this situation for
And
him.
I'm not the tallest person either, and there are much taller people that work here.
I believe the current man using this is 6'5". Yeah.